So we're done with speed. Speed और आएगा नहीं आपका. Speed has been bye bye. Okay. So from today we introduce our next character, and that is velocity. Velocity में बहुत सारे facets आएंगे. Speed was very simple, only speed and average speed. Speed was distance traveled by time taken, SI unit being meters per second, and also we learned 1 kilometer per hour is 5 by 18 meter per second. Okay, now we're going to learn about velocity. So velocity is defined as the ratio of displacement over time. Displacement, rather we should say change in displacement, not displacement. It's change in displacement by time taken. Okay, velocity is said to be change in displacement. Just like in speed we say distance by time, it's actually change in distance. So velocity is change in displacement over time taken. Okay, change in displacement over time taken. Now try to understand. Some things will be new for you now. Change in displacement, change. Whenever we talk in physics about any quantity called change, or later on in economics as you study change, change is denoted by a Greek letter which is called triangle, and this stands for delta. 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 So in high level meetings, people will say, suppose you are trying to buy a table and I am proposing one more table and I'm saying it is much more stronger, we can go with this table. So you'll see people talking in a language saying, how much is the delta? How much is the delta means they're asking, how much is the price difference? Delta stands for change, or delta also stands for difference. Have you understood? Difference. Now, change in displacement. Okay. Change in physics is said to be final quantity, that is the final value minus initial value. Any change in physics is final value minus initial value. Now listen, my first term score was 10 marks I got. In second term I got 8 marks. So in physics the change will be negative because it will be 8 minus 10, which will give me how much? Negative 2. फिजिक्स में नेगेटिव हो या पॉजिटिव उससे हमें कोई मतलब नहीं. ऑलवेज रिमेंबर, चेंज इज ऑलवेज अ फाइनल वैल्यू माइनस एन इनिशियल वैल्यू. देयरफॉर इफ आई टेल यू व्हाट इज द चेंज इन स्पीड, फाइनल स्पीड माइनस इनिशियल स्पीड. व्हाट इज द चेंज इन प्राइस, फाइनल प्राइस माइनस इनिशियल प्राइस. हु इज बिग हु इज स्मॉल इज नॉट माय botheration. What is the change in displacement, final displacement minus initial displacement. Have you heard it? Have you understood? Okay, book में आपको सीधा लिख देगा displacement by time. It's not displacement, it's the change in displacement. So in velocity we are talking about change in displacement. So we'll write change in displacement. So, and start getting accustomed to this language. Change in displacement will be what? Final displacement minus initial displacement. Is that fine, children? Displacement as a quantity in physics will always be represented by S. And in American books, they will represent by X. We will represent it by S. Displacement is represented by the letter S. समझ में आया? Okay. Now, understand. We are talking about something called initial and something called final. Can final happen without initial? क्या second year exams, first year exams हुए बिना हो सकता है? Never. Final can never happen before initial. Considering that this is the time axis, if you are going on time, the final match of a tournament will always be after the initial matches of the tournament. तो initial को हमेशा 1 पकड़ा जाता है और final को 2 पकड़ा जाता है. These are nomenclatures. Have you understood? So when we talk about displacement, displacement is denoted by S. So final displacement को हम कैसे लिखेंगे? S2. Have you understood? Initial displacement कैसे लिखेंगे? S1. Children, are you clear online? Everyone, have you understood? S stands for displacement. The suffix stands for the timestamp. 2 बोलते ही आप समझ जाओगे ये बाद का कांड है. 1 is पहले का कांड because 1 comes before. And this should be, yeah, please tell me. Somebody was saying, yeah.
Displacement is sometimes zero.
Yeah.
So, can there be any possibilities where x can be smaller than 1?
What I'm least bothered about smaller or greater. We will take displacements by sign value. So there is no confusion. If the final displacement is -3, we will take -3 minus that way. Okay. Now, change in displacement means change is always denoted by delta. So this is delta S. Have you understood? So what does delta P? Delta P means change in price. Final price minus initial price. Delta M, the change in my marks. Final marks minus initial. So we should also have change in displacement by time taken. So time taken means same as change in time. Or rather than writing change in time, so that you don't get confused, I'm saying time taken. Children, I will take it up, don't worry. Time taken. And time is always कैसा रहता है? Time taken is always पीछे कोई जाता है, पीछे जाते हैं. कौन जाता है? भूत, पिशाच, राक्षस, दैत्य, ये लोग पीछे जाते हैं. इंसान में टाइम यू कैन कैच, टाइम हमेशा आगे जा रहा है. तो टाइम विल ऑलवेज बी फाइनल टाइम माइनस इनिशियल टाइम, है ना? टाइम में कभी भी कंफ्यूजन नहीं रहता है. हम पीछे जा ही नहीं सकते हैं फिजिक्स में, ठीक है? सो टाइम बिकम्स T2 as my final time minus T1, and I call this as my delta T. That is delta T is the time elapsed, time taken. इसका और एक इंग्लिश क्या हो सकता है? Time elapsed. कितना वक्त बीत गया ये चेंज होने में? So I'm now making it a little bit smaller, children. कितना वक्त हो गया ये चेंज होने में? Okay. Make it a little bit smaller so that you can see. Now, velocity is said to be the change in displacement by time taken. Displacement is denoted by the English letter S, small s. Therefore, and change is denoted by delta. Henceforth, wherever we talk about change, it will be always delta. And change is a final value minus initial value. Finals are always given 2 and initials are always given the value what? 1. Okay, don't worry. We'll clean this up. Initials are always given 1. So change in displacement is how much? S2 minus S1. Time taken is T2 minus T1, which is known as delta T. Are we fine? So we now are in a position to define velocity symbolically. So velocity is defined as V, and we write the V like this. We write the V like this. Practice करो. लिखना आना चाहिए. Cursive V. Okay. So velocity V will be given as delta S over delta T. आप 11 में जब जाएंगे तो velocity आपको ऐसे ही लिखेगा, delta S by delta T. आप अभी से सीख लो. What is delta S? Change in displacement. And if you want to understand velocity in a kiddo grade 9 language, then your book will also write it like this: displacement over time. Have you understood? But the perfect way to understand velocity is change in displacement over time elapsed. ठीक है? अब देखो, इसको समझने की कोशिश करते हैं. लिटिल बिट इनसे थोड़ा सा आपको अगर ऐसा लगे कि दिस इज हाई फंडा, बट इट शुड नॉट बी हाई फंडा, इट शुड बी सिंपल. जस्ट ट्राई एंड इमेजिन दिस इज माय frame of reference as we were speaking, right? This is my frame of reference, and let's say on this frame of reference I am showing displacement here and I am showing time out here. Have you understood? Initially my body is out, say somewhere here. Okay, rather than that, let me show it this way. Let's say my body is here. समझिए, अभी इसको समझना बहुत जरूरी है. What does this mean? That this was the time and this was my displacement or position. Have you understood? So I call this as my T1 and I call this as my S1. Have you understood? Now after some time my position has changed. Okay, my displacement has changed and we are finding the displacement all from the origin. थोड़ा टफ लग सकता है लेकिन समझिए कुछ टफ होना नहीं चाहिए. So this is my position of the body after some time. So I call this is my T2 and this is my S2. Have you understood? Right? Now how did the body move? Sir, the body has actually moved from where? The body has moved from this place to this place. Do you agree? This is, say, the position of the body. So, maza lijiye abhi. And it will not be tough. Just understand. This was position P1 of the body. Now the body has gone to a position P2. Have you understood? Okay. Can anybody tell me from the graph? Because graph समझना बहुत important है. What is change in displacement? Final displacement minus initial displacement. Look, this is the change in displacement. So if I draw my graph in this manner, just try to see in this manner, and I try to name my graph as, say, this is P1, P2, and let this point be some R point. Don't you think this is nothing but delta S? Obviously, S2 minus S1, है ना? और ये चीज क्या है? This is delta T. So in a right angle triangle, the perpendicular and the base, ये भी काम में आएगा बाद में. जब आप ट्रिगोनोमेट्री पढ़ोगे और आप वेलोसिटी को ट्रिगोनोमेट्री से देखोगे तब ये भी आएगा. Have you understood? I am explaining you in a very high level. Displacement over time elapsed. ठीक है? Clear? Okay. So velocity is given by displacement by time. As of now, we will revisit this graph again when we study graph. Don't bang your head, try to understand. So we got a new quantity. So now what should we be interested in? We should be interested in also saying what is the unit of velocity. What should be the unit? Obviously, displacement is a length. So unit will be meters divided by time, which is second, which is nothing but meter second minus 1. Is this clear? Whenever a new quantity comes, you have to say the unit as well as the nature, whether it is a scalar or a vector. Now next question comes, ये scalar है या vector है? देखो तो इसको जन्म देने वाला parent क्या है? Displacement. Displacement क्या है? Scalar है या vector है? Vector है. So velocity is also a vector quantity. Now this is the first difference that is coming with speed. अब धीरे धीरे स्पीड के साथ कंपेयर करेंगे. Speed's unit was also distance upon time. Velocity's unit is also, sorry, speed's unit was meter per second. Velocity is also meter per second. But velocity is a vector. Are you understanding? ठीक है? तो आइए यहां पे थोड़ा सा और लिखते हैं. Velocity is what? A vector quantity. And उसका यूनिट क्या है? Meters per second. That means if I have a body and let's say this is moving with a velocity v which is equal to say 20 meters per second, this is not sufficient information because it is what? It's a vector quantity. I should be saying that it is 20 meters per second and I should also specify the direction that it is going towards the east side. समझ में आया? करेक्ट. इतना तक समझ में आया? इतना में कोई भी कंफ्यूजन है तो बोर्ड को आराम से देखिए एंड आस्क मी. इफ यू आर नॉट आस्किंग दैट मींस यू आर नॉट, you're just copying things. I don't want that. Please understand if there is any doubt, because after this we will be slicing velocity much more deeper और deep slice करके देखेंगे इसको. अभी हमने सिर्फ velocity के definition को सीखा, उसके unit को जाना, graphically velocity कैसा रहता है वो देखा, और velocity है vector है वो देखा. तो लिखने के टाइम पे velocity should also be represented by its direction. Any question at this moment? Okay. Can I go ahead? हाँ.
clearly understand what is velocity, what is velocity, so like how is it applied, what is the effect.
That we will see now. Wait all. Some more examples let me give, then it will start becoming clear. Still then, if it's not clear, I'll come back to your question. Hold it. Right. Are we fine so far? Okay. So let's go one more slide now. Now, let's see what all we understood. Previously, we had read about something called speed. What was speed? Distance, that is the change in distance or distance traveled over time. Now, parallelly start looking at velocity. Velocity is displacement over time. Have you understood? Now, let's see the difference between the two. Well, if we talk in terms of unit, then unit wise there is no difference. This is meter second minus 1. This is also meter second minus 1. If we talk about the quantity, then this is a scalar because its parent is a scalar and this is a vector. Still it is not coming clear to us. Actually our difference क्या है? आइए देखते हैं. What was distance? Distance was the actual length of the path traveled by a body, irrespective of its direction, right? So let's take an example that we have a body and the body is right now where the body is right now, let's say, on my frame of reference, right? Let's say I am measuring distance on this side and I'm measuring time on this side. My body takes a path and it has reached a point here. So it started from its initial point, say A, and reached a final point B. Okay, it reached a final point B, right? Rather than copying, pay attention. I'm again saying pay attention. ये सब नया चीज नहीं है. Dipti, pay attention. Then only you will ask questions. If you are not asking questions, means it is not entering your head. A body has traveled from A to B. We want to calculate the speed. How will you calculate the speed in this case? The best way to calculate the speed graphically here would be take a piece of thread and start following this. Because speed is distance traveled by time. मजा आ रहा है अभी समझ में? Speed की definition होती है distance traveled by time taken. And what are my time axis? This is one time and this is the other time. So time में कोई problem नहीं है. Say this is the time t1 and this is t2. So if you try to calculate speed, then speed के denominator में it will always be t2 minus t1. Agreed? If you try to calculate velocity, इसके denominator में भी आएगा t2 minus t1. That is the time taken. But in the case of speed, it is the length of the yellow path because speed is dependent on the distance traveled. है ना? तो मान लीजिए the length of this all Jingbang path is say roughly some 27 meters, roughly, and this is so many seconds, roughly. What is 27 meters? The length of this Jingbang yellow loop. But when we are talking about displacement, displacement क्या है? Shortest straight line path. तो displacement calculate करने के वक्त हम क्या calculate करेंगे बेटा? हम यहां से एक straight line बनाएंगे यहां तक. क्या करेंगे? We will just make a straight line from here to here. And I will measure only the length of this straight line. Because this is displacement. Are you understanding? बहुत अच्छी बात है. तो ये displacement में मान लीजिए ये value हमारी आई some 11 meters. This is also second. Now do you see the two quantities are coming totally different? Huh? Speed is a vector. So sorry, speed is a scalar, displacement is a vector. So every vector quantity is represented like this. See, any vector quantity will be represented by an arrow on its head. Write down. Any vector quantity is represented by an arrow on its head. Some books might print like this. Majority of the books will print like this. However, few books may also print it like this. How they will print it? they will print it like this. वो ऐसे प्रिंट करेंगे, बोल्ड में प्रिंट करेंगे. Many American Russian books will print it like this in bold. Bold means it's a vector. Have you understood? Rather, generally all other books will be printing it as what? They will print as with an arrow on the head. Is that fine? Now, this is a vector. A vector has what all, children? Has a magnitude and also has a direction. Majority of the problems which we will be doing in grade 9, we won't be that much bothered with direction. So we will be dealing with what? Magnitude. अभी भी मैं जो निकाल रहा हूं ना 11 meters by say this time is some 5 seconds, ये मुझे magnitude ही बता रहा है. What is this telling? Magnitude. So the magnitude of a vector is represented like this. If you put it between two bars, this means this is standing for magnitude. तो जो आप यहां पे speed लिखे हो ना, if you try to properly say, then you are actually, this formula is giving you only the magnitude. समझ में आया? This is the magnitude. और magnitude को कुछ books कैसे लिखेंगे? कुछ books magnitude को लिखते वक्त arrow को हटा के सिर्फ letter को लिखेंगे. That means also magnitude. That's why your grade 9 books are writing V equal to so and so. All they are referring to is magnitude. But speed is a vector. ठीक है ना? Sorry, velocity is a vector. So अगर velocity vector है, velocity का direction क्या है? पहला बात आता है ना? Velocity is a vector. So we have addressed the magnitude part. The magnitude comes from the formula delta S over delta T. ये तो समझ में आ गया. Sir, how will we say about the direction? Then think about the parent. Who is the parent? Displacement. Displacement नहीं तो इसको जन्म दिया ना. अब displacement का direction देखो. बड़ा इंटरेस्टिंग है. मैंने क्या बोला था? The body moves from A to B. So what is the direction of displacement? This is the direction of the displacement. It is going from A to B. So what is the direction of the velocity? Same A to B. Velocity tailgates displacement's direction. अब इसकी velocity किस तरफ है बेटा? Towards A to B. Same as the road. So if somebody tells me what is the direction, we will say the direction is from A to B.
Sir, A to B cannot be a fixed direction. A to B can be any way, right? A to B can be from north to east to west.
How can A to B be north to east when these two are frozen? When these two are frozen, how can it be in any other way? I don't think it can be in any other way. Shortest straight line when I have said. How can it be in any other way, beta? Tell me.
No, sir. Something have the distance as A to B.
Distance has nothing to do with. Hang on. When you are talking about speed, then you are worried about what is speed, then you are worried about distance.
This direction and distance, right? I use wrong word. Not direction, distance.
Distance. I'm saying this is a case given to me where there is no question of doubt in distance. This is the path taken by the body. You may now argue with me, sir, from A to B, he should have gone by some other path. हो सकता है. But to me, this is the question given. So this is the distance. What is 27? 27 is actually the length of the yellow path. For this particular example, that is distance. एक ही तरीके से गया. In one way he went. But when we calculate the velocity, we are interested for the displacement. We have nothing to do with 27. We will be calculating what is the shortest straight line distance. Have you understood? And here, if you actually see, now all mathematics will come at its place. If you actually want to calculate how much is the shortest straight line distance, isn't it not a right angle triangle? Yes, this is a right angle triangle. This is what, beta? Delta T. Do you agree? What is this? This is delta S. So what should be your delta V or delta? This is your delta S and this is your, sorry, this we will not bring at your level now. You keep it up till here. Delta S upon delta T. You will not understand slope now. So have you now understood? This is the displacement. Now, when we talk about displacement, we have now given what is the magnitude of displacement. We should also talk about the direction. Velocity है तो suppose this was a rocket. What is the velocity of the rocket? 11 by so many seconds. In what direction? We will say in a direction of an angle given by say theta with the horizontal. इस angle में velocity है. समझ में आया? Okay, you might be confused by this. This letter is known as the letter theta, Theta. This is the Greek letter theta, which stands for any angle. Okay? Have you understood? अब मजेदार चीज देखिए. Discussion is still not over. Let me take one more example where my body, instead of now going to B, has actually traveled a distance like this. Look at the distance, how the body is traveling. The body this time is traveling through a distance in this manner. Look, it is going from here, 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 and finally the body is ending up here. Okay? This was say B1 position. This is B2 position. आइए speed calculate करने की कोशिश करते हैं. Speed will be now the length of the yellow loop. Say the yellow loop is 63 meters divided by the time T2 minus T1. Have you understood? Let us find out what is the velocity now, the magnitude of velocity which is represented by V. Can any bachcha now tell me what is the magnitude of velocity now? Then I'll understand you are understanding physics. इधर देखो, ग्राफ देखो. Change in displacement by time. Time कितना लगा आपको? वही time है ना? T2 minus T1. What is the change in displacement? Displacement ग्राफ के किस एक्सिस में है वो देखिए. किस एक्सिस में डिस्प्लेसमेंट है? बॉडी की पोजीशन पहले कहां थी? अभी ए मतलब बॉडी की पोजीशन कहां थी? जरा देखो तो. बॉडी की पोजीशन कहां थी? The body's position was here. Agreed? इतना घूम घाम के भी बॉडी की पोजीशन कहां है? Where has the body come? Don't see here. This is a plot of displacement and time. Just see it on this axis. This axis is representing nothing but the distance. This axis is representing time. Modern है, मान दीजिए. Previous example में the initial displacement was where? Where was the final displacement in the previous example? Not B. B was the position. The final displacement was here, S2. And this gave you nothing but, this gave you delta S. Have you, वही तो delta S था ना, ये delta S है तो ये भी delta S हुआ ना, rectangle form हुआ. अब अगर आपका, अभी आपका displacement कहाँ है? Final displacement. Final position is this. इसका displacement देखें. ओहो, body has not moved from its initial position. Yes, the displacement in this case is 0. So the value of velocity is how much? 0. This gives us the first difference, while speed can never be 0 because he has covered some distance to go here. Velocity cannot be 0. Oh, sorry, speed cannot be 0, but velocity can be 0. Have you understood? Now you should say, search, there should be a third example also. Say suppose उसका final displacement position यहाँ आ गया, B3. B3. Are you understanding? Now, where is his final position? Somewhere here. This is S3. Don't you think S3 is a smaller value than S1? So this time my delta S will be a negative quantity. Yes or no? My delta S will be a negative quantity, means my velocity can be negative also. But if you look at speed is never negative because, sir, how did you go from here to here? My wish, I must have gone something like this and reached here. I must have gone something and reached here. Speed can never be negative. ये आपको डिस्टिंग्विश में ऐसी बुक में लिखा रहेगा, स्पीड डिस्प्लेसमेंट जीरो, क्योंकि आप यहां पे इस डिस्प्लेसमेंट एक्सिस में देखिए ना, आपकी पोजीशन पहले यहां थी, अभी आपकी पोजीशन आप सोच रहे हैं यहां से यहां गया, ये तो टाइम एक्सिस है ना बेटा, ये टाइम है, टाइम यहां से यहां गया. एक्स एक्सिस इज रिप्रेजेंटिंग टाइम, डिस्टेंस इज रिप्रेजेंटेड बाय y axis and this is a short line distance. ये लूप्स है, लूप. तो अगर आप इसकी पोजीशन देखो, ये बॉडी यहां था, मतलब ये इसकी पोजीशन है, दिस इज द डिस्प्लेसमेंट फ्रॉम ओरिजिन. घूम घाम के बॉडी यहां आया तो डिस्प्लेसमेंट. बॉडी को यहां नहीं दिखा सकता हूं ना बेटा, क्योंकि टाइम तो आगे जा चुका है. ये सुबह 8 बजे है, अब दोपहर के 12 बज चुके हैं. तो पोजीशन समझ में आ रहा हो, टाइम तो जाते रह रहा है ना, टाइम वी कैन नॉट स्टॉप. आर यू गेटिंग इट? सो नाउ आई से लाइक दिस, I once again go back to my slide and look how I'm now changing it. If these things become clear to you now, you will not have any problem in higher grades. Let's see. Let's see back. Let's go back to speed. Speed. 1 minute, children. Speed is said to be distance over time. Now you put your mature thought. This is what? Scalar. Second thing, what? Can never be zero or negative. है ना? तो बस अब इसके ऊपर लिखिए, speed can never be zero, speed can never be negative, speed is always a scalar. Have you understood? अब ये तीन चीज समझ में आया. That diagrams, no, those graphs nobody will ask you in exam. These you will write in, आपको आएगा question distinguish between speed and velocity. जो आप लिखोगे रट रट के आपको समझ में आना चाहिए. Why speed can't be zero? Because distance travel can never be zero. Displacement can be zero. मैं सारा दिन घूम घाम के, और look at your daddy, अपने पापा को देखो, he lives from where? Home. सारा दिन घूम घाम के वापस कहां आ जाता है? Home. तो जो कहता है ना आज बड़ी थकान वाली मन, पापा फिजिक्स के मुताबिक तो आपका डिस्प्लेसमेंट ऑफ द जीरो. Yes or no? A pilot and a cabin crew, they leave their base station, पूरा इंडिया घूम के उड़ उड़ के रात को फिर अपने बेस स्टेशन आ जाते हैं. डिस्प्लेसमेंट क्या है? जीरो. बट डिस्टेंस कवर्ड माइल्स एंड माइल्स. उनकी वेलोसिटी जीरो है, उनकी स्पीड जीरो नहीं है. क्या ये चीज समझ में आया? ठीक है. अब बात करते हैं इसी में वेलोसिटी की. वेलोसिटी इज व्हाट? डिस्प्लेसमेंट ओवर टाइम. डिस्प्लेसमेंट क्या है बेटा? वेक्टर है. डिस्प्लेसमेंट क्या हो सकता है? जीरो भी हो सकता है, नेगेटिव भी हो सकता है. एक कॉमन क्वेश्चन आपके लक्ष्मी सिंह में है, a bus travels early morning from Delhi to Jaipur and in the evening it comes back to Delhi. What is the displacement? Zero. What is the distance travel? 300 kilometers. 150 one way, 150 the other way. एक क्वेश्चन है आपका, तो ये समझ में आ गया. तो यहां से हम वेलोसिटी को क्या लिखेंगे? Velocity is a vector. Understood? I'll take a lot of time in this chapter. ये clear होना है आपको. Velocity is a vector. Velocity can be zero. Velocity can also be negative. Why? Because उसका डैडी जो है displacement वही negative होता है. And in grade 9, whenever you are calculating velocity and all, you are only calculating the magnitude of velocity. हम डायरेक्शन पे इतना नहीं करते हैं. So grade 9 you will see velocity being written always like this, delta s by delta t, or some books will write as s by t. All you are doing here is that you are only reporting what? The magnitude. But when you go to grade 11, it will be written like this. Look in grade 11 how it will be written. V is equal to डेल्टा एस के ऊपर भी बार रहेगा. वाई? डिस्प्लेसमेंट भी तो वेक्टर है, और यहाँ पे क्या रहेगा, डेल्टा टी. दिस इज हाउ इट विल बी रिटन इन ग्रेड 11. दिस इज हाउ यू आर राइटिंग नाउ. समझ में आया? क्या कोई वायरलेस कम्युनिकेशन हो रहा है तुम्हारे दोनों के बीच में? कुछ तो चल रहा है तुम लोगों का. हाँ, हमारे को बेवकूफ मत समझो, हमारी आंखें पीछे भी है. इतना क्लियर आया? ओके. अब जरा बात करते हैं फिर से वेलोसिटी को देखते हैं. वेलोसिटी, इट इज व्हाट? इट हैज अ डायरेक्शन and it also has a magnitude. Now let's look at this magnitude. Let's look at the magnitude. तो हम क्या बोलते हैं? Let's say this is position 1. Say body कहाँ गया? Straight line, position 2. Right? This is what? Delta S. And say the time was t1 here and this is t2. So how will I write my v? How will I write my velocity? Velocity will be delta S by delta t, which is nothing but s2 minus s1 divided by t2 minus t1. Now, I am dealing with the magnitude. My question is, can I not say that this magnitude is also a type of speed? This is also a type of speed. Look at me. I am calling this magnitude as a speed. What is speed's definition? Distance by time. ये भी तो कुछ ना कुछ डिस्टेंस है, लेकिन एक फर्क है. क्या? ये कोई आड़ा तेरा डिस्टेंस नहीं है, शॉर्टेस्ट डिस्टेंस है. दैट मीन्स वी शुड से शॉर्टेस्ट डिस्टेंस को एक और भाषा में कैसे लिखें? वेयर डिड यू वांट टू रीच दिस? इफ यू वांट टू रीच फ्रॉम हियर टू हियर इन शॉर्टेस्ट वे, कैन देयर बी 3-4 ways? Never. There can be only one way. So I write that the magnitude of velocity is speed in a defined or specified direction. ये बहुत बड़ा स्टेटमेंट है. Can you say that velocity is same as speed? Well, for the same journey it may not be, but velocity's magnitude is same as speed in a defined direction. Have you understood? किसी प्रॉब्लम में अगर आपको बोला कैलकुलेट स्पीड और आपको डिस्प्लेसमेंट दिया है, that means you are calculating velocity's magnitude. If you are calculating speed using distance, then you are calculating speed. If you are calculating speed using displacement, you are calculating a special class of speed, that is the speed in a defined direction. And such a speed is nothing but the magnitude of velocity. ठीक है कि नहीं? अब इन सब चीजों को कंबाइन करके स्पीड को भूल जाते हैं. एंड लेट्स कम बैक. सो दिस वाज माय पोजीशन 1 एंड आई एम गोइंग स्ट्रेट हियर टू पोजीशन 2. दूसरे पोजीशन में गया. एंड लेट्स से द डिस्प्लेसमेंट is equal to s. Now I'm coming back to grade 9. आपके grade 9 में आता हूं. And the time taken was equal to say t. So what is the velocity? S upon t. What is this? This is nothing but only the magnitude of velocity. Magnitude. Direction abhi hum utna. And this magnitude is also, can also be said that it's speed in a defined direction. It's speed in a defined direction. Why is it speed in a defined, and what is that defined direction? I would say यहां से एक horizontal ले लीजिए अगर आपको इतना इंटरेस्ट है, और फिर यहां से बोलिए this angle is some say 60 degree. So I say what is the defined direction? 60 degree with the horizontal, or I can say it is 60 degree northeast, है ना, northeast की तरफ जा रहा है. अब कोई confusion नहीं. What is the velocity? The velocity is s by t. What is the velocity's direction? 60 degree northeast. What is the speed? The speed is s by t. Is this speed same as, I mean, what is so special about the speed? This speed represents the magnitude of the velocity, and it is the speed calculated by using the shortest straight line distance between A and B. That means, sir, for calculation of this speed, there has to be a defined direction. Oh yes, it has to be 60 degree northeast, nothing more than that. अगर आप कुछ और करेंगे तो आप 2 नहीं पहुंचेंगे. सोच लो, समझ में आया? So what is velocity? Velocity is the ratio of displacement over time. Velocity is a vector quantity. Velocity is magnitude is speed in a defined direction. Have you understood? Velocity और अभी और मजेदार चीज है, अभी रुक जाओ. Velocity is said to be displacement. Velocity can be zero if after traveling all way the body comes back to its original position. Velocity is zero. Velocity can be negative. Velocity can be positive. Whereas the speed that we had learned, that can only be positive. वो कभी negative नहीं हो सकता है. इतना चीज समझ में आया? अब एक सुंदर सा चीज देखिए, एक मजेदार चीज. Let's say we have a DVD disc. This is a DVD disc. क्या हो गया समर्थ? Disturbed है? This is a DVD disc. And this DVD disc is rotating. ये rotational motion है, sorry. This DVD disc is rotating. है ना? और मैं कहता हूं this is rotating at 1500 RPM. Now you will ask, what is RPM? Revolutions or rotations per minute. Means every 1 minute it is rotating how much? 1500 times it is rotating. Fixed है ना? तो ये तो फिक्स हो गया. ठीक है, अब सवाल देखते हैं. Let's say we take 2 points on this DVD. Let's take 2 points on this DVD. This is one point A and this is one point B. And let's say on this DVD, 2, what do you call, honeybees are sitting. What is the speed of this honeybee? 1500 RPM. What is the speed of this honeybee? 1500 RPM, and they are at rest. अब फिर से सुंदर देखो, बाहर से देखेंगे तो we'll see both the honeybees in motion, but this honeybee will never see this honeybee in motion. It will see this honeybee stationary. It will only, it's like merry-go-round. Have you merry-go-round में बैठे हो? घोड़ा और घोड़ा में बैठने से तुम और मैं हमेशा पास पास ही रहते हैं, सामने आसमान, the surrounding keeps on moving. You can't go away from me in a merry-go-round. हमारे घोड़े तो उसी जगह पे है ना. मजा लो फिजिक्स का. Okay. My question is, can you tell me what is the velocity at A? Is the velocity at A same as velocity at B? The speed of this disk is 1500 RPM. The disk is moving at 1500 RPM. That means कभी भी देखो इसका स्पीड कितना है? 15. Like this fan. ये फैन अभी एकदम एक कांस्टेंट स्पीड में घूम रहा है. My question is, what about the velocities here and here? Are the velocities same? What is velocity? It has a speed, it has a direction. Think in that line and try to answer. Speed मैंने आपको बता दिया है. ये हनीबी कितने में घूम रहा है? 1500. ये हनीबी भी 1500 में घूम रहा है. Are their velocities same? सोचो.
So is the velocity zero?
How can velocity? Same नहीं है. देखो, इसकी वेलोसिटी है VA, इसकी वेलोसिटी है VA. अगर आप मुझे अभी पूछो ना दोनों की मैग्नीट्यूड क्या है, now see it's most interesting thing of physics. देखो, if you see what is the magnitude of this, I will say 1500 RPM. इसकी मैग्नीट्यूड, this is VA, this should be VB, sorry, okay. The second honeybee, this is also 1500 RPM. And this makes you conclude that the velocity is same. Hang on. You have just commented on the magnitude. You have not commented on the direction. अगर कभी ये हनी बी स्लिप कर जाता है, ठीक है, अगर ये हनी बी स्लिप करेगा तो ये हनी बी का पोजीशन कैसा होगा? आई डोंट नो वेदर यू गेटिंग इंटरेस्ट और नॉट. ये हनी बी टेंजेंशियली छिटकेगा यहां से. सोचो, आप एक रस्सी ऐसे से घुमाते हो ना, और जब छोड़ दोगे तो वो सर्कल में जाएगा, जिधर से जाएगा वहीं से फूटेगा. Have you seen discus throw? What does he do? And then he turns and releases it. It just releases tangentially to his orbit. यही तो बात है. कभी आप घूमर घूमर डांस खेलिए किसी लड़की के साथ ऐसे पकड़ के और घूमिए. हंसने की बात नहीं ना. सोचो, जोर से पकड़ के रखते ना. At the time the tension is, and you just betray the other girl. ऐसे छोड़ दो उसको. That girl will not go on around. वो छिटक के वहां पे गिरेगा जहां से भी गिरना है. तो ये हनी भी कहां छिटकेगा? इस साइड छिटकेगा. वो हनी भी कहां छिटकेगा? Tangent to this part. Now tell me, are their velocities same? No, their speed is same. We will revisit this when we talk about uniform motion, uniform circular motion. This is uniform circular motion. हर पॉइंट उतना ही स्पीड में घूम रहा है, हर एक का डायरेक्शन अलग है. ये वाला बच्चा जब छिटकेगा ना, इस साइड छिटकेगा. जब आप चाबी घुमाते हो ऐसे करके, आपकी मम्मी बोलती है ना, डोंट डू इट, किसी को भी लग जाएगा. क्यों लगेगा? वो तो सर्कल में घूमेगा, जहां छूटेगा वहीं से टच करके जाएगा. You see all those movies where people try to climb, वो जो मराठा टाइप मूवीज देखते हो ना, रस्सी ऐसे ऐसे घुमा के कैसे छोड़ते हैं, ऐसे छोड़ देते हैं, वो टेंजेंशियली फ्लाई करेगा. हैमर थ्रो देखा है ओलंपिक में? हैमर थ्रो जहां एक रस्सी टाइप लेके ऐसे घुमाता है, ऐसे ऐसे घुमा के और फिर थ्रो करते हैं. वो सर्कल में जाता है क्या? स्ट्रेट जाएगा. इट विल ऑलवेज गो टेंजेंशियली. नाउ डू यू अंडरस्टैंड? वेलोसिटीज नीड नॉट बी सेम, बट स्पीड विल बी सेम. स्पीड सेम है, बट वेलोसिटी को छेड़ने के लिए क्या छेड़ दो? या तो मैग्नीट्यूड छेड़ दो, या फिर डिस्टेंस छेड़ दो. ये जब आप 11 में पढ़ोगे रोटेशनल, अभी आपको 11 में क्या पढ़ाएगा पता है? यहां पे एक हनी भी ले आएगा, उसका क्या होगा? उसका वेलोसिटी अलग हो जाएगा. Try and think. If there is one honeybee out here, if there is one honeybee out here, ये honeybee कैसा घूम रहा है? ये honeybee ये छोटा वाला सर्कल घूम रहा है ना, और ये honeybee, and these two will always be in the same position. हाँ, कम डिस्टेंस, तो इसको स्पीड कम रहेगा, इसका स्पीड ज्यादा रहेगा, इसको उतना घूम के आना है. हाँ, वहां पे मैग्नीट्यूड भी अलग हो. ये रोटेशनल मोशन में आप 11 में पढ़ेंगे. तो अगर वो कॉन्सेप्ट आपको क्लियर तभी चाहिए. सो डोंट गो बाय योर सिंपल दैट एनसीईआरटी बुक ओनली. ट्राई टू थिंक एंड ट्राई टू अंडरस्टैंड, देन ओनली यू विल अंडरस्टैंड facets of physics. Is this clear? Okay. Now comes our next concept. Okay, where did it go? All right, that's right. Our next concept about velocity. So we have understood a lot about velocity. Now velocity, मान लो there is a change in velocity. Suppose we have a change in velocity. So I told you a change is always given by delta, and there should be, now you are trying to find delta V, and hence on I am going to talk only in magnitude, because in grade 9 we don't have direction of now. Change in velocity. Change in velocity means what? Velocity has changed. मतलब फर्स्ट टर्म में एक वेलोसिटी रहा होगा, सेकेंड टर्म में भी एक वेलोसिटी रहा होगा. Change in velocity. So when a velocity changes, obviously I should have something which is known as initial velocity, and I should have something called final velocity. Initial velocity will be denoted by v1, final by v2, and delta v will be given by v2 minus v1. तो आप अभी लॉजिक समझ में आ रहा है? कैसे कैसे हमने पढ़ा था? डेल्टा टी को कैसे लिखते थे बेटा? T2 माइनस T1. और डेल्टा टाइम में हमेशा फाइनल माइनस इनिशियल, हम कभी पीछे नहीं आ सकते. कैन यू गो बैक टू यस्टरडे? नो. डेल्टा एस मतलब क्या? चेंज इन डिस्प्लेसमेंट. डिस्टेंस वी हैव फॉरगॉटन, स्पीड वी हैव फॉरगॉटन. हेंस ऑन आवर स्टोरी विल बी गोइंग ओनली विथ डिस्प्लेसमेंट. डिस्प्लेसमेंट इज गिवन बाय S2 minus S1. Change in velocity is given by v2 minus v1. Is this clear now? Okay. Now, यूनिफॉर्म मोशन पढ़ा था, है ना? अब टाइम आ गया पढ़ने के लिए यूनिफॉर्म वेलोसिटी. वेरी इजी एंड सेम डेफिनेशन लाइक यूनिफॉर्म मोशन. छोटा एक चेंज है खाली. सुनो, वेलोसिटी कहां से पैदा होता है? डिस्प्लेसमेंट से. डिस्प्लेसमेंट का डेफिनेशन क्या है? शॉर्टेस्ट स्ट्रेट लाइन पाथ. Whenever you talk about velocity, whenever you talk about displacement, children, don't forget one line. ये straight line, इसको मत भूलना कभी भी. जो कुछ भी हो रहा है, shortest straight line. Our chapter number 1, hence on we'll talk everything on velocity, displacement. That means one thing we should conclude. इसके आगे, if our chapter says a body moves, if the chapter says this word body moves, you should understand that it is always moving in a straight line. This is the first conclusion of your first chapter. Body moves means the body is always moving on straight line. Why is this body in our chapter not moving like this? ऐसा move ही नहीं कर सकता है grade 9 में. Why? Because we are discussing only displacement and velocity. Displacement cannot happen in this manner. Displacement can happen this. Let's say what all things can happen. The body can move like this. Your whole chapter is like a snooker board now. सब कुछ straight line में होगा. कर्व हो ही नहीं सकता है. कर्व 11 में आएगा. समझ में आ रहा है? Body moves in straight line in this chapter. So let's see what is uniform velocity. So we will say a body is said to travel with uniform velocity. सुनो पहले समझो. A body is said to travel with uniform velocity if it travels in a straight line, first criteria, and covers equal distances in equal intervals of time. Now you will say, sir, why didn't you not use the word displacement? My dear friend, I have already used the word straight line. In a straight line, if a body is traveling distance, then it is automatically displacement. Yes or no? है ना? तो कैसे लिखेंगे? A body is said to move in uniform velocity, move in or move with uniform velocity if it travels in a straight line. Straight line word बहुत important है. And covers equal distances in equal intervals of time, no matter how small the time intervals are.
And how is it different from motion?
That straight line word is not there. Vakul, in uniform motion, you just need to ensure that the body is covering equal distances in equal intervals of time, no matter how small the time intervals are. Are you getting it? The body can move curve, 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 curve. It only has to, see, uniform motion means my body could have moved like this. If this is say 5 meter and this is 6 meter, in the next instance also it should cover how much? 6 meters only. And say this is 1 hour. So 1 hour is too much. So let's say this is 1 minute. Here it's also 1 minute. This is uniform motion, a body covering equal distances in equal intervals of time. What is uniform velocity? Uniform velocity is when the body is moving in a straight line and is covering equal distances, or you can write the word displacement also, no issues. Equal displacements in equal intervals of time. Samajh?
Here, there is a straight line. That's the examples of 5 meters, 6 meters, 8 meters. So let's take each point as A.
Yeah, this is point 1, point 2, point 3, point 4. So we are trying to say that our body, let's say we analyze the motion only between 1 and 2. So we ask, how much time it took? Sir, it took a time of 1 minute. How much was your displacement? Sir, 5 meter was my displacement. Okay, let's analyze between 2 and 3. How much time you took? Sir, I took 1 minute. How much was the displacement between 2 and 3? Sir, 5 meter. So this is now a body is in uniform velocity.
So here, we analyze the distance between point 1 and 2, or can we also analyze between the starting point and final point?
If you see starting and final, then that is a separate analysis.
Okay, so
Okay, what Vakul is asking is also very interesting. What he is asking is, if he wants to know between say 1 and 5, then from 1 and 5, these are not the displacement. From 1 and 5, the displacement is this. Have you understood? And this displacement will be broken into small time intervals. and you should ensure that between equal intervals, equal displacements are covered.
Understood, sir.
Did you get it? ये समझ में आया? What we were saying is these are all small displacements. यहाँ पे uniform velocity, uniform velocity, uniform. He's saying, sir, what about 1 and 5? 1 and 5 अगर लोगे, then 1 is the initial, 5 is the final. The shortest straight line is now this. This is the net displacement. इसको छोटे छोटे भागों में डिवाइड कीजिए, equal time intervals. And we added a word, no matter how small it is. So you should be able to break it in many small time intervals, equal intervals. And you should always find one thing. In this small interval, agar ye blah blah gaya hai, so in the next small interval also you should go blah blah only. Agar ye tlatla chala gaya, to ye uniform velocity nahi hai. A body, and what is non-uniform velocity? A body is said to move with non-uniform velocity. इन तो मत लिखिए, इस वर्ड को रिप्लेस करके विथ कर दीजिए. We replace this word and we make it as with. A body is said to move with non-uniform velocity if it travels in a straight line but covers unequal distances in equal intervals of time. Straight line में जा रहे हैं. I am traveling from here to there. I am traveling straight line. But I suddenly started walking fast. I am going with non-uniform velocity. Are you understanding? 1 minute बिटू. Say suppose you have a billiard. जब हम बिलियर्ड्स खेलते हैं ना, पूल में आपका बॉल कभी भी कर्व होके नहीं जाता है क्रिकेट की तरह. Pool is always a straight. As a best example, between one strike, it is a displacement, but the ball starts slowly and then picks up speed. Pool का hit is not uniform velocity, क्योंकि वो जाता straight line पे है, पर वो हर एक short intervals में speed is not. The speed picks up slowly. है ना? But if a ball was say rolling at a constant speed, then I can say it is uniform velocity, क्योंकि बॉल रोल होके आ रहा है, यूनिफॉर्म रोल होके आ रहा है. ऐसा हो भी तो सकता है ना? जैसे आप ऐसे ये कर दो, इंक्लाइन प्लेन कर दो और यहां से फुटबॉल छोड़ दो. फुटबॉल को कौन बुलाएगा? मदर अर्थ इज सेइंग कम टू मी, कम टू मी, कम टू मी. फुटबॉल स्पीड लेगा. That is a displacement, but not uniform velocity, because initially the ball will come slowly. जैसे ऊपर से पत्थर गिरेगा तो क्या प्यार से आ गया क्या तुम्हारे पास? धीरे धीरे रोल कर जाएगा ना. ये अगले चैप्टर में पढ़ेंगे that whenever there is a force, you do not have uniform velocity. Then comes the birth of something called acceleration. That's why when the Titanic starts going down, Mother Earth starts pulling it, and the Titanic won't go down slowly. It will go down with a speed. 4 मिनट में टाइटैनिक सैंक हो गया, 11 किलोमीटर नीचे चला गया अटलांटिक के. 4 minutes. Are you imagining how much speed it picked up? That we will study after this. Is this clear? So today what you have learned so far, what is velocity? इसके बाद अगर आज के बाद आपको कोई पूछे कि आपका अभी तक का कवरेज क्या है, by now children, check on these parameters again when you are visiting. Do you understand rest? Do you understand motion? Yeah, you will take your doubt, don't worry. Do you understand distance? Do you understand displacement? Do you understand speed? ये सब खुद को पूछिए, और कोई भी चीज नहीं समझ में आएगा दोबारा पूछ. Velocity. Do you understand what is scalar? Do you understand what is vector? Do you understand what is uniform and non-uniform motion? Okay, and do you understand what is uniform? Please write it. I want you to write it. And non-uniform, take bead, you keep a watch on eye on the watch. Velocity. Do you understand what I mean by velocity as speed in a specified direction or specific direction? Ask yourself question about all these things. If you say you have understood all, then you are a very rare species. मैं बार बार बोल रहा हूं, आप बहुत ही रेयर हो अगर आपको सब समझ में आ गया क्लैरिटी से. और इसके लिए आप किताब भी पढ़िए, आप इंटरनेट देखिए, आपको जहां से आए बस आप सवाल पूछिए कि ये मुझे समझ में आया है या नहीं. अगर नहीं आया है तो क्लियर करके ही आगे जाएंगे. And I also said our ball will always hence on roll in a straight line. Why? Because so far, अच्छा speed के बाद हमने एक और चीज यहाँ पे पढ़ा था. I forgot. That was average speed with the formula total distance traveled by total time taken. ये भी पढ़ा था. और velocity आज जैसे ही पढ़ा, we are holding it at initial velocity, final velocity, VI, VF. Yes, sir. Tell me. Yes. Absolutely slowly you can tell me. तू घड़ी देख. हाँ. ये तो कॉपी कर लेना ना रिकॉर्डिंग से. Yeah. Go ahead. Sorry. Go ahead, Bitu.
Yeah. So does the object actually maintain uniform velocity, or is it?
See, I will tell you a question. Okay, you have got out from your house in a car. Okay, the first question, very nice question. Does an object maintain uniform velocity? In order to maintain uniform velocity, Kartika, the first thing is straight line. Do you think the shopping mall that you're going to go will be straight line from your house? No, never. You might fall off into a cliff, or you might fall off into some pond. In our daily life, you cannot have uniform velocity. How is it possible? Because the bus, once it leaves your house, it takes a right turn, then left turn, then takes a loop, then gets on. So the first criteria itself is defeated of straight line. Yes or no?
Yeah.
So you, in reality, you don't get uniform velocity like that. It's not possible. However, when we talk in terms of physics and we say that you have shot some sort of an arrow or a projectile, an arrow is actually going in a straight line. So we have obeyed the straight line factor. An arrow is going in straight line. Just as the example that I gave, let's say this is my park in the garden, a sliding ladder, and a cute little boy is trying to slide down it. Is the path straight line? Yes, we have followed number one. How do you ensure that the speed will be same at every point? Obviously, the boy has just pushed himself on the sliding ladder. He will have some speed up till here. The moment he comes here, his speed will increase because Mother Earth is saying, "Aja, aja." Gravity se pull kar raha hai. Yahan aate aate speed aur बढ़ जाएगा. So this will be a classic case of non-uniform velocity. Body is moving in straight line, but body won't cover equal distances in equal intervals of time. Initially, to travel say 12 inches, the boy may take 3 seconds. But in next 3 seconds, you will find the boy must have got some 20 inches. He will just roll down fast. Does that address your query? Your first query. Yeah, your second query.
Uniform velocity and acceleration.
Acceleration, hold on, because I have not yet explained you acceleration. If you okay, first thing understand, if you have asked it, children, 2 minutes, acceleration is a quantity. What was velocity as a quantity? Change in displacement over change in time. Acceleration as a quantity is change in velocity over change in time. Mark my words. Acceleration as a quantity is change in velocity. So if velocity changes, then only acceleration is born. And if velocity changes, it can never be uniform velocity. If velocity is uniform, then to ye paida hi nahi hoga. Just see, what is delta V? Delta V is V2 minus V1 divided by delta T. If you are talking about uniform velocity, then V2 has to be equal to V1. Your velocities cannot change. Uniform velocities means V2, V1, V3, V4, all velocities have to be same. Yes or no? Then if they are same, don't you think the numerator becomes 0? Yes. So acceleration ka to janam hi nahi hua. Yes. So I teach like this, that whenever you hear about acceleration, it should strike in your brain, velocity has changed. And now let's go to your car and listen what sound I make. If you're driving an automatic car, then on the right pedal, what do you have? In America, we call it the gas pedal and you call it the accelerator, you desis. What do we call it? Accelerator. As soon as you press the accelerator, how does the car say? Yes, that's because the velocity, the speed. And say let's put our car on a straight road. Our car is on a straight road. थोड़ा 5 मिनट दो यार, इतना टाइम देख के फिजिक्स नहीं होता है, नहीं तो ये छूट जाएगा. We are on a straight road right now, absolutely a straight road, and we have pressed our gas pedal and we are pressing it. Don't you think your speed increases? And now it is speed on a straight line. So we are talking velocity. And how is the car making a noise? It cannot be uniform. ये तो non-uniform है. लेकिन all of you have cars nowadays where you have cruise control. What is cruise control? You can fix the speed. Now we are on a straight road and we have fixed the cruise at 80 kilometers. How is my car going? Straight line, equal distances, equal interval. On the next lane, I have got Kartika with me, and they are traveling at 79. We are traveling at 80. We will be going like this, and in fact, we can put mascara on her eyes beautifully. No relative displacement between us, because both of us are going in the same thing. Do you understand? This is the beauty. यही तो मूवीज में दिखाते हैं ना, जेम्स बॉन्ड टाइप मूवी. एक ट्रेन से दूसरे ट्रेन कैसे क्रॉस कर रहा है. दोनों ट्रेन जब सेम स्पीड हो जाएगा, यू कैन जस्ट वॉक फ्रॉम वन ट्रेन टू द अदर. हाउ डज इट डिफर? लेकिन अगर दोनों में फर्क होगा, आप चलती बस से गिरते क्यों हो? क्योंकि जमीन इज एट स्टेशनरी and the bus is moving. Therefore, when you get down, you also start running till some distance. If you don't run, you'll fall. But say suppose if you know, sometimes have you seen train robbery movies? शोले type movie देखोगे तो घोड़े से ट्रेन को लूटते हैं. The घोड़ा will be made at the same speed like that of the train. The robbers are coming in horses. Movies देखा करो. So the horses will be at the same speed as the train. At that time, he will take out his rifle and he will just jump off to the train. That is the minimum jerk that he can get. Now, do you understand? Uniform velocity is possible. Is it possible? Yes. In Hyderabad, we will say when we go to the airport, and if the stretch is absolutely straight and you have actually pressed the cruise button, you are traveling at uniform velocity. Equal distances, equal intervals of time, straight line. But जहां आप थोड़ा सा स्टीयरिंग घुमा देते हो ना, सत्यानाश हो गया. क्यों? डायरेक्शन चेंज हो गया ना. सर हमने तो क्रूज कैंसिल नहीं किया था, तो क्या हुआ? आपने मैग्नीट्यूड नहीं छेड़ा, पर आपने डायरेक्शन छेड़ दिया. So if there is a small kiddo, थोड़ा सा स्टीयरिंग ऐसे करने से यूनिफॉर्म वेलोसिटी बर्बाद हो गया. वेलोसिटी को बिगाड़ने के लिए या तो डायरेक्शन छेड़ दीजिए या मैग्नीट्यूड छेड़ दीजिए. या
I have a doubt.
three questions.
Example.
Hey, their faces have become all you. Now you finish your 3 questions. Their faces have become weird now.
The base example is the car stop. After the car stop, and let's take a starting point is when the car stops speed, and the final of the ending point can be the velocity.
First of all, I got lost in your question. Your question was so long. What is question number 2? Can we hear that? No issues. We will see velocity. We don't see velocity in everyday life. First of all, let me tell you, your car does not have a velocity meter. Your car has a speedometer.
Okay. Last question is, why can velocity not be a straight line ever?
No, not possible. Velocity is the person who gives birth to velocity is displacement, and displacement always goes in straight line. Your question is like, sir, can we be indisciplined in your class? In my class, there may be no education, but there has to be discipline. So it's ruled out. Okay, we'll understand velocity. अभी पूरा साल पढ़ा हुआ है. Many children have not understood velocity at grade 12, my dear. You have at least, you're honest, you're saying that I have not understood. What's the big fuss? We will understand. So that in grade 11 you become strong. Let's clear it from now. चलो रंगारंग कार्यक्रम खत्म करते हैं. बहुत हो गया. Need to go home. Right, bye.